Howdy guys! In this video, we're going to look at average rate of change and speed of an object, such as maybe a rock that has been dropped off of a cliff or maybe a high building. All right, so this is a fairly accurate equation here for planet Earth. So if an object is dropped from a high cliff or a tall building, then the distance in feet it has fallen after t seconds is given by the function d of t equals 16t squared. We're going to find its average speed or its average rate of change over the following intervals. First, from between 1 second and 5 seconds. What's its average speed? Meaning from 1 second after it's dropped until 5 seconds after it's dropped, right? The speed increases, as you might imagine, due to gravity, right? But what's its average speed, okay? So the way we're going to do that is see how far it's fallen because speed in general, you may recall, is distance over time. So if speed is distance over time, then we need its distance. How far has it fallen, right? So let's find distance at time 1. If we plug in 1 for t squared, we're going to have 16 times 1 squared. I'm going to just jump to 16, right? And the distance 5 seconds after it has fallen, that one we may need a calculator for. Let's grab that real quick here. And so for that one, we're going to plug in, it's big, let me make that smaller here, 5 into the t squared, 16t squared, right? So we're going to do 16 times 5 squared is equal to 400. Okay, 400. So here we go. All right, so change in distance over change in time, right? Average rate of change is, for practical purposes, average speed. It's actually average velocity, but for this problem, it's basically average speed. Okay, so how far had it fallen? Well, it went from 16 feet to 400 feet. So the change in distance, how far it traveled from 1 second to 5 seconds, is the difference, right? Let's write it all out. That would be d of 5 minus d of 1 all over 5 minus 1. D of 5 is 400. D of 1 is 16. And all of that is over 4. So 400 minus 16, that's 384. And I will do that last calculation on here real quick. So 384 divided by 4 is 96, okay? So it is going on average 96. Now the units of distance is feet and the units of the time is seconds. So it's an average of 96 feet per second. Now here's the thing, right? When something falls like that, it starts out going a little bit more slowly and then it gains speed as it falls due to gravity. So it's not really going 96 feet per second on the entire time interval. That's just its average speed. Okay, so we're going to do this in kind of a different way, a unique way, right? Because we're introducing the h version of the difference quotient. So to find its average speed from 1 second to 1 plus h seconds, right? What do? Well, what we're going to do is the same formula, change in y over, or change in distance over change in time, but I'm not going to plug in a number for h, right? You'll kind of see why as we do this. So it's basically saying from 1 second to 1 plus some number of seconds, okay? So we'll figure that out in just a minute. Let's start with just the computation and the simplification here. So average rate of change would be distance at the second time. The second time is 1 plus h. So d of 1 plus h minus the distance at 1 second. We already calculated that, 16, divided by the change in time, which is 1 plus h minus the initial time of 1, right? The 1 plus h is right there, minus that initial time of 1 right there. Okay. So d of 1 plus h, that is a formula right here. We're going to plug in 1 plus h for t, and so that would give us 16 times, if we change that t to 1 plus h, we'll have 1 plus h all squared, minus d of 1 is 16, and all of that is over, well, 1 plus h minus 1. Those parentheses aren't doing anything. I just added them in to kind of group the 1 plus h together to make that a little more obvious. But yeah, that one will cancel with that one, leaving us with just h in that denominator. All right, we want to simplify it. Now, we could multiply everything out, multiply it all by 16, but I think it'll be easier to just factor the 16 out. That will make the computations a tad bit easier. So I'm factoring the 16 out of both this term and that term. So that leaves me with parentheses 1 plus h all squared minus 1 for taking that 16 out of that 16 right there, all over h. Now we need to simplify, so we're going to FOIL that out. So we have 16 times. If I FOIL out 1 plus h squared, that is not 1 squared plus h squared. We have to FOIL. 1 plus h times 1 plus h. So the first two terms are both 1. The outside term is 1 times h, if you can imagine. Maybe just show you what I'm doing, right? 1 plus, well, there we go. 1 plus h all squared, right, is equal to, let's make some room there. There we go. 1 plus h times itself. Can I move? Yes, I can. 1 plus h. There we go. We're going to FOIL that. So the first two terms make 1. The outside term is positive 1h. Inside term is also positive 1h. And the last term is h squared. So those middle two terms, h plus h, make 2h. So 1 plus 2h plus h squared. That's that FOILed. Hopefully you can do that in your head. If not, there it is. So 1 plus 2h plus h squared right there. And then that is minus another 1. Oops, I really didn't need that parenthesis there, did I? Let's fix that. All right. All of that is with the 16 up front, and it's all over h. Okay, we're almost there. All right, as you can see, then that one with that minus 1 do cancel. And we can then take an h out of everything. So let's factor an h out of that numerator. I'll factor first, then cancel. I like to say it that way. Factor first, then cancel. So 16h, if I take an h out of here, I'm left with 2 plus h all over h. So h divided by h, those h's cancel. And so we get 16 times parentheses, 2 plus h. I think we'll go ahead and distribute it this time. So 16 times 2 is 32 plus 16h. All right, what is that? Well, that is a formula for the average rate of change between 1 second after the object is dropped and 1 plus h seconds after it's dropped, right? So we have to plug in a value for h, right? So what would h be if you are going like we did up here from 1 to 5? Well, if you're going to from 1 to 1 plus h, the h is the distance between the two times, right? Well, what's the distance from 1 to 5? Right, to get from 1 to 5, you add 4. So that means the h would be equivalent to 4 if you are going from 1 to 5, because 1 plus 4 would be 5. Okay, so now what we're going to do is kind of a shortcut. We're going to plug in h into this answer above, that's this one right here, to see the average rate of change from t equals 1 to t equals 5. Right, so then when we get, let's label it, average rate of change would be 32 plus 16 times 4. Let's bring the calculator back real quick and just type that in. So 32 plus 16 times 4 is on 96, just like we got before, right? So you can see that whether you find a formula for your average rate of change between 2 points based on this h, right? Or you just compute the numbers, you get the same thing. Now, the point is there is a reason for the h, right? And it goes into what you're going to do in calculus to find instantaneous rate of change, which would be instantaneous velocity. Okay, that's where this is leading towards. So there's a reasoning behind this. It may seem a little weird at first, though. All right, so also, I think we'll just end that one right there. And the next video, what I'm going to do is find the difference quotient in terms of x and x plus h and plug in some numbers and work through some more examples. But that's just kind of a quick intro into that concept.